Welcome back to B-Spice. In this session, again we'll continue with fire and gas detection system. So this will be part 2. If you are a first-time viewer, I just want to inform you, fire and gas part 1, we have already covered yesterday in fact. So wherein we focused on the fire detection system, such as, smoke detectors and a smoke detector in the sense HSD, ionization, photoelectric, all we covered. And also the flame detectors, ultraviolet, infrared 3, and the heat detectors, rate of rise, fixed temperature, and frangible bulb sprinkler system. All those we covered in part 1. Okay. So in part 2, we'll focus on these aspects. This in the sense catalytic gas detector. So this is the first and foremost. Catalytic gas detector, flammable. See, okay. Catalytic gas detector are based upon the principle that when gas oxidizes, it produces a heat. Very simple. Okay. When the gas oxidizes, it produces heat. And the sensor converts this heat, I mean the temperature change, via a standard Wheatstone bridge type circuit to the sensor signal that is proportional to the gas concentration. Very simple. You got it, friends? So the sensor consists of a pair of heating coils, meaning reference and active. So this is how it works actually. Again, friends, this is an outline. That's why I'm actually covering more notes in oral way actually. Orally, I have not furnished anything in this slide actually. Okay, you can comment also if that way is okay. Whether it's good to have this kind of what do you call oral information instead of written information. Anyway, coming back to this subject. So again, catalytic gas detector. This is one of the gas detector, flammable. This is based on the principle that when gas oxidizes, it produces a heat. So, and the sensor converts this temperature change via standard Wheatstone bridge to a sensor signal that is proportional to the gas concentration. So that is how it works. And the second item here is infrared pointer, infrared point detectors and infrared open path detector. Infrared point detectors and infrared open point detector. Okay. So infrared detectors generally are used for detecting flammable gas, and they come in 2 points. I mean main types. So that is what I mentioned here. One is the point detector, other is the open path detector. Okay. So so what are all the features here actually for point detector? We'll talk about point detector. See, point detector, we have a fixed absorption path, meaning this detection, these detectors have a fixed absorption path length, typically a few inches. Okay, and also localized detection. They measure gas concentration at a specific point, making them ideal for monitoring small and confined areas. As the name you can make out, right? This is a point detector, localized detection. Then also fail-safe operation. So they use a two wavelength, active and reference, to ensure fail-safe operation. Okay. When we talk about the application, it's commonly used in industrial environment like refineries and chemical plant to monitor gas leaks. That's it. Okay. So when we talk about the open path IR detectors, the features is extended absorption path. So there it is fixed absorption path. So here it is fixed absorption, here it is extended. So extended in the sense this can have an absorption path of up to 200 meters. So whereas in the point it is actually few inches. Okay. Okay. Then second point related to this open path is wide area monitoring. They are designed to detect a gas over a large area, making suitable for perimeter monitoring. You got it, friends? Then it has a separate transmitter and receiver. Okay. All right. Then application, of course, used in predominantly in petrochemical and petroleum for rapid gas leak detection. Okay. So here, friends, both type of detectors are infrared. Use infrared light. That is the point. Okay, right. And of course, they are immune to poisoning, resistant to corrosion, and do not require oxygen to operate, making them reliable and of course low maintenance options for gas detection. I hope you got some insight on this. Then when we talk about the electrochemical gas detector, toxic, so how this actually works? Okay. So the sensing mechanism, I'll touch upon a bit on the sensing mechanism. See, basically this detector uses an electrochemical cell, where a chemical reaction occurs when the target gas is present. You got it, friends? So this reaction generates an electrical current proportional to the gas concentration. Very simple. So the sensing mechanism in electrochemical gas detector is it uses an electrochemical cell where a chemical reaction occurs when the target gas is present. That's it. This reaction generates an electrical current proportional to the gas concentration. Then, when we talk about the select detection, it is a selective detection, meaning they are designed to be highly selective for specific gases only, such as carbon monoxide, hydrogen sulfide H2S, and chlorine. Okay, this is selective detection. And when we talk about the low power consumption, so basically it consume very little power, making them suitable for battery operated devices. Again, when we talk about the application, industrial safety, used in industries, manufacturing, oil and gas, all this. And what else? Also, it used to detect pollutants and ensure quality in various environments. That is also there. Yeah, that's it on application point of view. If you talk about the advantage, it is a high sensitivity and accuracy, high sensitivity and compact and portable, cost effective, of course. But the problem here is a limited lifespan actually. So that is the issue. So yeah, these are the things I just want to put forth here. Then we'll talk about the metal oxide, MOS. We call it as a MOS, metal oxide semiconductor gas detector. Okay. So this is also effective for detecting toxic gases. Then again, we'll talk about the mechanism, how it works. See, this MOS detector uses a metal oxide semiconductor layer. There it is a electrochemical, but here it is a metal oxide semiconductor layer. Typically tin dioxide, which changes its electrical resistance when exposed to a target gas. Very simple. That's it. So it has a metal oxide semiconductor layer which changes its electrical resistance when they're exposed to target gas. Okay, that is a sensing mechanism for this MOS semiconductor gas detector. And other feature actually it has a heater element. A built-in heater maintains the sensor at an optimal temperature in the sense usually between 200 to 400 degree to enhance sensitivity and response time. That is the point. And when we talk about the gas interaction, see, when toxic gas molecules interact with the metal oxide surface, they alter the resistance. That is how it works. This change is measured and converted into electrical signal. As usual, when you talk about application, industrial safety, it's, carbon monoxide, all these toxic gases detection. And yeah, environmental monitoring also, and of course, used for residential and commercial safety. And advantages, again, high sensitivity, durability, cost effective. Limitation, again, power consumption. Actually, it requires a continuous power supply. Yeah, that's it. So yeah, that's a MOS. Then next, ultrasonic gas detector. This is flammable and toxic. See, yeah, flammable and toxic. So how it detects leaks of flammable or toxic gases by sensing the ultrasonic sound waves produced by the escaping gas. That's it. So let's see how it works. Again, sensing mechanism. So as I highlighted, it actually uses sound wave. So it uses microphones to detect the ultrasonic sound wave generated by gas leak. Okay. The sound waves are typically in the frequency range of 20 kilohertz to 100 hertz. That is a point. Okay. So that is it's using sound waves. That's it. Then here one advantage also I want to inform you. Here no gas contact needed. Unlike other gas detector, the ultrasonic detector do not need to come in contact with the gas because they detect the sound of the gas escaping and making them effective even in windy or ventilated environment. So that is the point we need to take note of. Then apart from that, it provides a real-time detection, friends, because it provides a real-time detection, allowing for immediate response to the potential hazards. An application point of view, of course, industrial safety in petrochemical and other industries, toxic gas detection, and also it's used for perimeter monitoring because of a large area, right? So yeah, then advantage, of course, fast response time, wide coverage area, maintenance free. Limitation is a concern. Limitation in the sense, the background noise actually. High level of background noise can sometimes interfere with the detection. So that is the issue. And initial cost is very high. That is the point. Okay, friends. So this is about the, gas detection system, the additional gas detector. Again, friends, to sum up, okay, just recollect under gas detection. See, we are now focusing on fire and gas detection system. Under that, we are covering detection. Okay. So under detection, we have covered smoke detector, wherein the HSSD, ionization, photoelectric, then flame detector, ultraviolet, infrared, infrared 3. Then we talked about heat detector, rate of rise, fixed temperature, and frangible bulb. Then additionally, catalytic gas detector, infrared point and infrared open path, electrochemical gas, metal oxide MOS, and ultrasonic. You got it, friends? Good to go? Okay, that's it. So additional to that, we will talk about the manual alarm station. We call it as a MFA. Okay, this will be installed along escape routes, entrance to all safety and fire areas. You would have seen this manual alarm station. Okay, so yeah, this is basically, okay, I'll talk about this, the functionality, how it works. As you know, it's a manual activation. So this device allows individuals to manually trigger a fire alarm by pulling a lever or pressing the button. You would have seen in the buildings, right? Yes. And once activated, they send a signal to the fire alarm control panel, which then initiates the building alarm system to alert occupants and emergency services. That is the point. Okay. Then types, actually, there are a lot of types. Single action station, meaning it requires only simple operation, only one action, like one action in the sense just pull down a lever to activate the alarm. So that is one thing. And common use, this commonly used in, the buildings, public buildings. This is for the single action. Then dual action. So in dual action, it's basically a two-step activation. One is, lifting the cover and then pulling the lever. Okay, that's it. And of course, enhanced security is there because you don't have to, it will prevent the accidental activation if it is without cover. That's it. An application point of view, again, commercial buildings, educational institutions, industrial facilities. And advantages, of course, reliable, simplicity. Limitation is the issue. What is the limitation? Here, actually, limitation means human intervention is required. That is the only limitation, friends. So this is about the gas detection system. So in fire and gas, we have covered the gas detection system. Okay. So yeah. Okay, friends, I think we are done with gas detection. We'll move on with the uh, what do you call protection system. Okay. So protection system in the sense, just give me a moment. Yeah. So protection system. Okay. Protection system. What is the use of this? This is used to alert plant personnel, initiate shutdown action, and activate fire protection system. Okay. So basically, the fire detector and gas detector give input signal to the FNG system, resulting in automatic protective action, right? And confirmed fire. There is some terminology I want to talk also in the protection system. Confirmed fire means activation of two detector in a cluster of detector working on a voting principle. You got it, friends? Very important. Confirmed fire means activation of two detector in a cluster of detector working on voting principle. Confirmed gas means defined as an activation of two detector in a cluster of detector working on the voting principle. So fire and gas detected by one single detector shall always initiate alarm in CCR. Fire and gas detected by one single detector in high risk area shall start fire water pumps. These are some of the design aspects. Okay. A single fire and gas detector shall only be considered if sensor head is self-monitored with the fault detection. That is the point. Okay. In case of confirmed fire and confirmed gas, we have to take all these actions. What is this? Alarm in control room, fire station, audible and visual alarms through PAGA. Okay. See, if there is a confirmed fire and if there is a confirmed gas, we'll have an alarm in control station. We have a fire station and visual alarms through PAGA, right? Then initiate shutdown sequence through ESD. Initiate HVAC shutdown damper closure. Activate start sequence of fire pumps. Activate fire protection system. That is, gas suppression or water suppression system. So this is about the, what do you call, protection system actions. Okay. Then we talk about the, what do you call, the design consideration. Okay. So this is very important when we work on the design. So fire water pump start signal shall be direction from FNG logic in addition to the local starting facility. Okay, I think there is a typo error. So fire water pump start signal shall be directed from the FNG system logic in addition to the local. We should have a logic also, we should have a local also. FNG system shall be located in a dedicated room with accommodation facility and with a dedicated VDU with the video display unit with the full graphic display located in CCR for continuous monitoring. Of course, yes. So FNG system shall require minimum maintenance and has a comprehensive self-checking and diagnostic fault detection capabilities. Of course, nowadays all vendors are giving this, no worries. And FNG system shall be powered from the emergency power supply. That is also, we should have a minimum, backup for 24 hours upon loss of main power, electric power. Upon loss of emergency power, then system shall be powered from monitored UPS, the battery bank, right, for a minimum of 30 minutes. So all cabling, external equipment which are associated with the FNG system shall be routed, located and protected in a manner which minimizes the possibility of damage arising from explosion, fire or physical aspects. These are some of the things, and of course few more to add. Field equipment shall be able to withstand the environmental and mechanical loads and impacts due to rain, wind, dust. So basically it has to meet the hazardous area classification and the IP rating, all this. And yeah, this is what. Field equipment which is located in mechanical ventilated unclassified areas shall be used in zone 2. Okay. Then if it is located in a mechanical ventilated classified area 1 and 2, zone 1 and 2, in all naturally ventilated areas shall be certified for use in zone 1, gas group 2B and temperature class T4. So these are some of the aspects we should take care. And of course, for battery room, gas group 2C is required. So that's all I have about this fire and gas detection and protection system, friends. If you have not watched the part 1, you watch. I suggest you all to watch. So this is more of an outline only, just to give you some idea. Okay. The next video, I'm going to bring you the detailed specification also. On that video also, I'm going to talk more. I'm not going to put many items in the slide. I'm going to talk more. So if you are okay with that, I'm okay. If you have any concern, let me know in comments. You want a detailed, then I have to modify and upload it. Okay, friends. Thank you. Take care. Bye-bye. And my request to all of you, show your support either by pressing the thumbs up button or by subscribing or possible become a member. Just to show the support for all the efforts B-Spice is put in for your benefit. Your benefit. Thank you. Take care. Bye-bye.